Hi everybody, these are Unit 11, notes number 4. We're now moving on to special parallelograms. Now this is only part 1 because today we're going to talk about the rectangle and the rhombus. But next section of notes we're going to talk about the square, all of which are special parallelograms. So basically what you'll see is that we're starting with a parallelogram, but we're going to change it in just a little way to make it a little bit more special. So the first one we're going to talk about is a rectangle. A rectangle is a parallelogram. It's got opposite sides being parallel, etc. But what makes this guy so special is that it's got 4 right angles. So I always say, picture that you had this parallelogram, which kind of already looks like a rectangle that's been pushed over. Well, now he's just going to go ahead and straighten up, giving himself 4 90-degree angles, of course, all being equal, and now you've got the rectangle. But once we do that straightening up, there's a bunch of other stuff that you'll notice. So right here for some key ideas with rectangles, first and foremost, this is what we just talked about. All angles are congruent. They're all 90 degrees. Just like the parallelogram, and I'm going to put a little P there to remind ourselves that just like the parallelogram, opposite sides are congruent and parallel. So that did not change. All that really changed was this angle idea that they're all congruent. Well, because all those angles are congruent and we've straightened up, not only, like the parallelogram, are the diagonals bisecting each other, but in addition, the diagonals will be congruent. So picture, I'm just going to go ahead and kind of draw in the diagonals into this picture up top here. Notice that they are the same length. No longer do you have kind of that one corner that seems kind of stretched out, creating a super long diagonal. Now everybody straightens up, so now the diagonals can equal out. Just like we talked about with the parallelogram, the diagonals will break up the shape into 4 triangles. I had a little typo here, guys. This is fixed on the notes sheet if you printed it out from Google Classroom. But just so we're clear, yes, a rectangle is a parallelogram, but I want to specifically talk about the rectangle. So my bad on that one. All right, so the diagonals will break the rectangle into not only 4 triangles, but 4 isosceles triangles. And of course, the opposite triangles are congruent. So just kind of showing you back up top here, now that these 2 diagonals are equal, that means that this will be equal to this. And this will be equal to this. So if you just take a look at the top and the bottom triangles here, they both have those same 2 congruent sides, and they've got that angle in the middle, so they are congruent and they're all both isosceles. So let's take a look at those key concepts with just some smaller problems here before we get to the real big ones. So for number 1 and 2, we're finding the values of the variable in each rectangle. So I would have to tell you that it is a rectangle. Even though I know it looks like one, I will have to tell you that, so don't worry, I will let you know when you're working with a rectangle as opposed to a regular parallelogram. And if you take a look at number 1, because it is a rectangle, let's think about the first thing we talked about with the rectangle, the idea that all the angles are 90. So if I come down here to this corner, I know this is definitely equal to 90 degrees. So now all I have to do is 90 minus 50, and that will give my value of x. X is going to be 40 degrees. And then just so we didn't forget about just the idea of a parallelogram, we know that opposite sides are congruent. So y is just asking you for that length of that side. Well, just like the regular parallelogram, go ahead and look to the opposite side. The opposite side is 6, so therefore that tells me that the y is 6. 6 inches will be the length of that side. And number 2, notice that we've got 2 diagonals here, crisscrossing right here in the middle. And just like we drew in the rectangle up top, I know that these diagonals are going to be congruent. And because the diagonals bisect each other, basically if I see a 4 or any number on one part of the diagonal, I've got 4s everywhere. So not only is x equal to 4 because he's part of that same diagonal, but we also have y being equal to 4 because in a rectangle, all the diagonals will be congruent. So again, you're given one little part, you can fill that part in for everybody. And that's what kind of makes the rectangles cool. So now let's take a look at one where I ask you to find a little bit more. And by a little bit more, I mean a lot. These are my favorites. We had one like this with the parallelogram. Now we're going to see it with the rectangle. So we've got diagonals MO and NP intersect at point Q. And we want to find all these indicated lengths and measures. And of course, they specify that we are talking about a rectangle. Now again, you can go in any order on your own, whatever kind of pops out to you. I guess I'm going to kind of try to go in order just to give ourselves a little bit of structure. So if I'm looking at the first blank they want MN, the length of MN. Well, MN is this top part right here. Well, just like a regular parallelogram, I know that opposite sides are congruent. So if the top is what I'm looking for, I look to the bottom, and that will give me my answer. So we've got 30 centimeters technically for MN. NO, well, of course, that's just this right side of the rectangle. So if I want the right side, I look across to the left. That guy is 21.5, so now I know that he is 21.5. And we'll go ahead and write that in the blank as well. Now for the rest of them, we're talking about the stuff inside, the diagonal. So let's take a look at OQ. So OQ is this little part right here. Well, if I go ahead and continue the other side, I notice that there's an 18 in this top part. So therefore, I know there's an 18 on the bottom part. But now what's even, again, especially cool about this rectangle is that all of these pieces, all these little parts inside are going to be the same. So since this is 18, obviously this is 18, that's parallelogram rules. But now I know this guy's 18 and this guy's 18. So that looks like that's going to help me out with this next one, NQ, yep, right here to here, 18. NP is now just the entire diagonal, so we'll just add those up and get 36. So again, the cool thing about the rectangle and the diagonals is that they are congruent, so you really only need one part and you'll know all of them. But just like the parallelogram, opposite sides are congruent. So you gotta look to the opposite sides to look for any of the outside. Now let's take a closer look at our angles. So just like when we did the parallelogram, guys, you can use all sorts of stuff to help find these angles. You use alternate interior angles. You can use triangle sum. You can use linear pair, vertical angles, okay? So if we take a look at letter A, I notice letter A is down in this bottom corner here. Well, if you notice, up top here, there's a 36. Those are alternate interior angles. So again, the rectangle is just another parallelogram. So alternate interior angles still apply. So we've got 36 for angle A. And now let's see what's happening with angle B. All right, so angle B is up top, just where I saw that 36. He's the other part in this corner. Corner being the key word here, guys. We know that a corner in a rectangle is 90 degrees. So in order to get this part B, I'm just gonna have to go ahead and do 90 minus 36, and I should get 54. So we'll get 54 degrees right here for B. I'm just gonna fill that in so you can see that. All right, so the next part here is letter C. Now, if this were the parallelogram, I would have advised you to go ahead and take the two angles here, add them up, and subtract from 180, because this forms a triangle. And that you can still do. But I want you to think about something that we talked about on the other page. These diagonals break up the rectangle into 4 isosceles triangles. So if I just kind of highlight, I'm not sure how well we can see this, but if you just kind of highlight this right triangle here, notice that it's got an 18 and an 18. Well, if you've got two sides being congruent in a triangle, well then you know that two angles are congruent, and those angles will be the ones that are at the end of the congruent sides. So if this B angle is 54, we know that the C is also 54. Okay, so that's special to the rectangle. You don't necessarily have to break out the triangle sum to get this number. You can just pull it from the other angle. If you don't feel comfortable with that, you completely forget. All right, as long as you've got this guy here, you could always add them up, subtract from 180, and yep, you'll get that number, okay? But it is especially important that you remember this whole isosceles triangle thing, because sometimes you will not be given a number inside, okay? And then last but not least, we want letter D, okay? Well, again, just like we talked about before, lots of things that we could do to get that letter D, okay? We could find this linear pair angle here and then do the triangle sum. But thinking about what we just talked about here, this triangle up here will also be another isosceles triangle. So if this side equals this side, then I know that this angle equals that angle. So I know if this is 36, that tells me that angle D is also 36. Again, to confirm that, you can use triangle sum. You can find this angle here based on the fact that it's a 90, and then use alternate interior up to there. So many different ways to deal with that, okay? All right, so again, those types of problems, you know I love them. I won't have a problem on the homework or the quiz that has this many pieces, okay? But expect sometimes maybe even 4 different values that you'll have to find and then click on which ones are correct, okay? And let's just finish out the rectangle portion of the notes with some algebra. Notice in number 4, okay, I have not given you both diagonals, I've only given you one, and that's okay. Also notice, should have mentioned this before, in the directions I do tell you it's a rectangle, so all the stuff we've been talking about the rectangle, we can use here. So I guess the first thing that I notice is that I kind of really want to use alternate interiors, but then when I really think about this, these are not alternate interiors. Remember how in class we did that little Z trick for alternate interiors? That means that this guy is congruent to that guy. So the 6x here is not congruent to the 42. These are not alternate interior angles. So what I'm going to have to do is first find this angle here, and then that's the guy who I can set equal to the 6x. Remember that this is a 90-degree corner, so I just need to do 90 minus 42, and that will give me 48. So I know that this corner, this part of the corner, should be 48. Now I've got alternate interior angles. So now I can say, all right, 6x, he's going to equal the 48 degrees. And when I divide by 6, that will give me 8. Now I love to do problems like this because I like to try to catch people on this. So don't be the one I catch, guys. Make sure you're paying attention to the idea that this and this are not equal. If you're going to use alternate interior angles, you have to find this guy first. And then lastly, for number 5, okay, we've got both diagonals drawn in this triangle. And what we're told so far is that AI, that length of AI from here to here, this entire thing, is 100 yards. And then they give us this tiny little 3x plus 8. Okay, lots of different things we could do here. My suggestion, let's try to keep it as simple as possible. First thing I do know is that if this entire thing is 100, I know that the diagonals bisect each other, so that means that each of these parts will both be 50. Well, I also know because it's a rectangle that if I see a 50 in one part of a diagonal, I know there's a 50 in all the parts. So now right here, and this is, I didn't say, that's not a 50-degree angle, I apologize that it looks like that. But basically what I know now is that 3x plus 8, which represents the length from H to C, I know that that quantity is definitely 50. So again, diagonals in a rectangle are equal, and that's why we're able to do this. Solving our equation, we'll go ahead and move the 8 over to the right. That'll give us 3x equals 42. Divide by 3. And that will give us 14. And that's what we're going to do with rectangles. The second part of our notes are going to be about rhombuses, maybe rhombi. I'm not exactly sure which one's which, but rhombuses sounds good to me. And rhombus is another special parallelogram, okay? So again, like we started with the square, or I'm sorry, with the rectangle, we started with a regular parallelogram. Looks like that rectangle kind of pushed over. But now what I've done is instead of thinking about the angles here, notice what's happened is we kind of squeezed this in so that now all these four sides have the same length. The rhombus is what a lot of people tell me is a diamond. I don't think a diamond is actually a geometric shape. What we're really talking about is a rhombus. A rhombus is a diamond. So the key things about the rhombus, first and foremost, all sides are congruent. And again, because it's a type of parallelogram, they're obviously parallel. But this is the new characteristic that we need to remember. So all the sides are congruent. Now again, we didn't focus on angles because the angles actually don't change. So just like the regular parallelogram, so I'll put a little P there for parallelogram. So just like the regular parallelograms, the opposite angles are congruent. The ones that are on the same side, they're going to be supplementary. So unlike the rectangle, you do not have 90-degree corners, okay? In fact, for the rhombus, the 90 degrees actually comes somewhere else. So let's move on to the next key idea. Just like the parallelogram, the diagonals bisect each other. But now what also happens with them is that the diagonals are perpendicular. So you're going to have 90-degree angles, but they're going to be in the middle. So let me just go back up here to the rhombus and show you that real quick. So if I draw out this super long diagonal, and then this little tiny guy, so by the way, diagonals are not equal, that's just the rectangle. Basically what's going to happen is they will always cross at a 90-degree angle. So as soon as you have the diagonals drawn for you in a rhombus, you have 90s all in the inside. So again, for the rhombus, you'll find the 90s all on the inside. For the rectangle, you'll see them all in the corners. And then lastly, that kind of gives you an extra little thing that's special, is that your diagonals bisect each corner. So basically, when the diagonals come into each corner, they cut them in half. And what that's going to mean, and this is what the last thing is that these diagonals will break the rhombus. Another typo, guys, this should say rhombus. Yes, a rhombus is a parallelogram, but I just want to focus on rhombus. All right, the diagonals break the rhombus into 4 right congruent triangles. So every guy in here is going to have one of each of the diagonal lengths, going to have the hypotenuse all be the same, and then they're all going to have the same angles as well, based on this idea that the diagonals bisect each corner, okay? But let's start finding our values just to clarify that, because the rhombus I feel like has so much, and I don't want us to get confused. So moving on to 6 and 7, Notice the directions, find the values of variables in each rhombus. I have to tell you it's a rhombus or you cannot do it. Remember we talked about first was that the rhombus, all the sides are the same. So the fact that this guy is 29 means that not only will his opposite guy be 29, but also the 2 on the side. Okay, so for a rhombus, all the sides are the same. If you really want to think about it, guys, the rhombus is sort of like a square now that has been pushed over. So all the sides are the same. And then remember what we just talked about up top with the diagonals? They're always perpendicular to each other. So if you have 2 diagonals, guys, right off the bat, and turn your paper if you need to kind of verify, yeah, that's a 90-degree angle. That's a perfect little box there. Okay, so your y value here will be 90 degrees. And moving on to number 7, talking a little bit more about those angles. Okay, we had said right here, the second to last key was that the diagonals bisect each corner. So what that means is if you look at a corner in a rhombus and you're given one side, there's no math to be done. You just automatically throw the other, that angle, that 55, into the other side. Okay, so the x is 55. It has nothing to do with, knowing what the total here is. I have no clue. All I know is that if this is a rhombus and I see the diagonal shoot into that corner, these two will have to be the same. Now, as far as finding y, we've got a couple different ideas here, okay? One thing, just to kind of go back to a parallelogram and remind ourselves of some of that stuff, this entire angle, now that we know that it's 55 and 55, if we add those up, that gives us 110. So if this whole thing is 110, and this guy is on the same side, we know they're supplementary. So if I do 180 minus 110, I get 70. So the entire thing will be 70 in this corner. But again, I don't want the whole 70, I just want half of it. So if I divide that by 2, I get 35. It looks very tiny. Let me write that again down here. So the y is 35, and up top there, the x is 55. Now that is just one way I could do that. That was me just relying on my knowledge of the parallelogram and this idea of the diagonals bisecting each other. But maybe you were like, well, we just did something here that had 90 in the middle. Why don't I use that? All right. You know that this must be 90 because it's in the middle, it's where the 2 diagonals cross. So now just looking at that top triangle there, you can use triangle sum. You've got a 90 and a 55, add them up, subtract from 180, you get the 35. So just like with the parallelogram, guys, you can use so many different facts. You're still going to need to know a couple facts about each of these special guys, but then after that, you can still go back and rely on some of the things that we've done throughout the year. And that's what you're going to see as we get to our final page of notes here, where I give you a rhombus and I give you a ton of things to find, because that's what I like to do. Go big or go home. Oh, wait a minute. We are already home. Oh. All right, so we've got our rhombus here, and diagonals PR and AT intersect at point Y, and we want to figure out all these different values. All right, so the first thing they want is AP, which is this top part here. And if this had been a parallelogram, or if this had been a rectangle, I would have only had the choice to look down at the bottom to see how big the top was. But now that it's a rhombus, hey, wait a minute. I can look at any of the sides. All of these sides are the same. So the fact that there's a 13 on the side here means that they're all 13. So So I believe that even is what we're going to fill in for the very first two blanks. AP is the top, AR is the right side. Perfect. All right, moving on, we're looking for AT. Okay, so again, pointing out the diagonals do bisect each other, but unlike the rectangle, they're not going to be the same. Any of the shapes that are slanted like that, guys, the diagonals will never be the same. You'll always have one kind of pulled out further than the other. But we are given this part here, AY. So to get all the way from A to T, which is this next blank here, I just need to go ahead and fill that 12 in on the other side here. And then I got 12 and 12, and that will give me 24. Next one is RT. Oh goodness, RT, we got that one already filled in, right? That's just the bottom right here. I put that color away. And lastly, for the side lengths, now we're talking about RY. So again, just to clarify, diagonals bisect each other just like the regular parallelogram. The diagonals are not congruent, but that's okay. So let's do two little tick marks there. So we know that if this is 5 feet, then we know that this guy must be 5 feet as well. So that's giving me the length of RY. All right, now for the angles, my favorite part. All right, A is right there in the middle. Remember, a rhombus's diagonals are perpendicular. So they're gonna look a little slanted, turn the paper if you need to, but these are always gonna be 90s. So for the rhombus, the 90s are all in the middle. For the rectangle, they're all in the corners. So I know that A, without needing to know anything else, is definitely 90 degrees. For letter B, remember that other part that we talked about. We said that the diagonals bisect the corners. So basically whatever's on the one side will automatically go with the other side. So we've got 48 degrees for letter B. Things are getting real tight in there. I apologize if you have to zoom in there. All right, C. Goodness, where's C? Ooh, okay. So now just to note here, guys, remember what I said. If I do like a darkened swoop that kind of goes over the entire corner, that means I want the measure of that entire corner, not just part of it. That's why the C, if you notice, is just kind of like hanging out. I'll just highlight that there, right on top of that diagonal. It's because I want this entire angle. Well, the only way to get that is to either know the one that's opposite, which I know nothing up there, or to know the guy that is next to him, the same side interior. Okay, in fact, let me make a little note there. Same side interior. So let's find out that same side interior and then just use our supplementary thing. So we just determined that this was 48. So 48 and 48, well, that's going to give us a 96 degree for that corner. So then if I want to find C, I'll do 180 minus the 96. And I think my math is correct. That gives me 84. So I know that that entire angle, that entire corner in the C there is 84. Now, let's see, I'm running out of colors here. All right, so now my problem is that the last one I need to find is letter D. Now that guy is just half. He's just looking for this part right here, okay? So therefore, knowing that opposite angles are congruent, I know this entire thing is 84, and if I just want that one part, well, remember that the diagonals cut each corner in half. So if I just want D, I'm just going to take that 84 and divide it by 2, and that will give me 42 degrees. So my D is 42 degrees. Now again, that's going through a lot of different characteristics. You could have used a different approach. Maybe you looked for alternate interiors. If this is 48, then that means this is 48. You know you've got a 90 here. So now you can do 48 plus 90, subtract from 180, that gets you D. So that's why I love these, and this again is why we wait until the end of the year to do this unit, because you really had to go through everything else to even kind of have all of these different approaches, okay? All right, let's finish out our rhombus with a little bit of algebra. All right, so now, again, just like what we did with the rectangle, guys, just so you know, these are not alternate interior angles. If I was actually looking for alternate interior angles, well, basically, guys, this guy here would actually match up with that side up there. Well, at first, it kind of looks difficult because you're like, well, how do I know what that angle is? I don't know the whole thing. Oh, but wait, I don't need to know that. Because again, in the rhombus, the diagonals bisect the corners. So whatever's on one side, I'm just gonna throw that right on over on that side. So now if I'm looking for alternate interior angles, yeah, there it is, that's 30. Or maybe you pulled this 30 down here right away and then remembered the idea of the diagonals bisecting the corners. I don't really care as long as we know what to set equal to. So the 4x minus 14, we will set equal to 30. Add 14 over to the other side. That'll give us 4x equals 44. Divide by 4 and we'll get 11. And then lastly, if you take a look at number 10, again, just driving home this idea that unlike the regular parallelogram and unlike the rectangle, all your sides are the same in the rhombus. So it doesn't matter that these aren't opposite. It doesn't matter that they're kind of connected. We still know that they are going to be equal. So we've got 5x minus 9 equals 2x plus 12. And that's why it's so important, guys, that up in the directions, I tell you it's a rhombus. If I didn't tell you this was a rhombus, guys, I didn't give you any other information, you would be able to stop and say, Miller, this is whack. I don't know why I just said that. You wouldn't be able to do it, okay? So the fact that I tell you it's a rhombus means that no matter where you've got the outsides here, you can set them equal. Let's move our letters to one side, numbers to the other. Again, I'm going to move the 2x because that way I'll get a positive 3x. If I moved the 5x to the other side, I'd have a negative, and I just don't want to deal with that. But again, because I moved my letters to the left, I'm going to have to move my numbers to the right. It's a balance. That gives me 3x equals 21. Divide by 3, and we'll get 7. And that is the rhombus, okay? So just to review some of the key ideas, guys, the rectangle, very cool, got 90s in the corners, and the diagonals, they're gonna be equal to each other. The rhombus is reversed. The rhombus's 90s are all in the middle, and he doesn't have diagonals equaling each other, but he's got all the sides equaling each other. So that's why I like to do these together, guys, to make you realize that they're almost just kind of the reverse, the inside out, the reversible of each other, really, okay? Again, just like our parallelogram, other notes and stuff, guys, after you do them, after you take them, go ahead and go on Google Classroom to do the homework. Yes, it's optional, but it's always good practice. And if you get 10 out of 10, I give you a bonus point in your quiz. All right? So good luck. Let me know if you have any questions, and I will talk to you soon. Bye.